Kinematics and Vectors. Now, kinematics is the branch of mechanics which looks at the motion of objects, but we don't look at the forces that cause that motion. So for instance, we're not looking at Newton's laws. A major part of kinematics is projectiles, where we're looking at the motion of an object through the air, and we've covered this already, so this video doesn't look at anything on projectiles. And where we have variable acceleration, we have to use calculus. Variable acceleration, calculus. We're not doing that in this video either. What we're doing here is 2D motion, where we have either constant velocity or where we have constant acceleration. Example 1. A particle has an initial position vector of 3i plus 7j meters and a constant velocity of 2i minus j meters per second, which means there's no acceleration. We want the position vector of the particle at 4 seconds. So we have the formula where the position vector, so that's reference from the origin, is equal to the initial position of the particle, again reference from the origin, plus a displacement. Now for constant velocity we have this formula for displacement. So S equals Vt, which means we're going to replace this with Vt. So now we have this formula. So R0, the initial position, 3i plus 7j goes in here. The velocity, 2i minus j, goes in here. And then we have t, substituting in, we have this. And we can separate out the I and j components. It's quite useful to have all the I components together, all of the j components together, like so. And now we substitute in t equals 4, and we get r is equal to 11i plus 3j meters. So this is the position vector at 4 seconds into the motion of the particle. Part B. At what time is the particle due south of the origin? Now it helps to visualize the problem at this stage, so let's do a sketch. The initial position, 3i plus 7j. So from the origin, 3i plus 7j. Here's the particle. Constant velocity, 2i minus j. 2i minus j. The particle is moving in this direction. So as the particle moves along this path, it's due north of the origin. Anything above this line is due north of the origin. Anything below this line is due south of the origin, and that's what we're after, south of the origin. So the particle is moving until it reaches this point, so it's on the line. It's now neither north nor due south of the origin. So we need to work out some information about this point here, and then as time progresses it will now be due south of the origin, and it remains due south of the origin. So at this point the position vector, which is referenced from the origin, it has no vertical component. The j component is equal to 0. So let's have a look at the formula for the position vector, which is here, and this is the j component. It should be 0 at this point. So 7 minus t equals 0, so t is equal to 7 seconds. So at 7 seconds the particle is on this line, but when t is greater than 7 seconds the particle is now due south of the origin. So we need a value of t greater than 7.